So our first quiz will be on strong induction, and it will be about making postage or making certain payment. So okay, here's the question, a possible question. Show using strong induction that any amount of at least 18 cents can be made using 4-cent and 7-cent stamps. Okay, so in other words, Pn is this statement that n can be made and cents can be made with 4-cent and 7-cent stamps. Okay, that's the statement Pn, and I'm claiming to show what you have to show is for all n at least 18 Pn holds. Okay, so prove by induction, by strong induction. Two parts, the basic step or the induction step, the initial step, basic step. Now, this includes P18, but we have seen in this type of question you need to do more, okay? So, let's do P18 at least. How do you do this? How do you prove that P18 is true? Well, you do this by just showing a solution, okay? Do you see the solution? Yeah, 7 plus 7 plus 4. Okay, that's enough to prove P18. You give a solution for it. Okay, so that's how you could solve the problem, so to speak, to give for every number a solution. But there are infinitely many numbers. Good luck with that. Okay. So let's go to, but leave a little bit of space because we'll need to prove a couple more cases. Although we did the basic step for the induction step. Now, for the induction step to work, we need something. So the induction step is P, so let me not write it down with, it works for all values, so assume, sorry, I should say that. So in the strong induction there are two things. You assume something, assume it works for all values between 18 and n, like the given n that we work on, to prove Pn plus 1. Okay, proof. And what we always do is subtract. Now we have actually an option here. You can subtract 7 as well, but we always take the least amount. So I take n plus 1 minus 4. Okay, that is n minus 3. Now, if this is a value less than n, but the problem is that this value might not be in the range that I want it to be. Namely, if this is the range here, it might be that this is too small. For instance, if n itself is 18, and I'm trying to prove 19, so let's think about it. I need to prove 19. What happens? I'm going to use it. So how does the proof work? Let me perhaps first say that. So once we have Pn minus 3, if there's a condition necessary. We're going to have to work on this condition. So when is this true, that this is okay? So something has to be said here, but let's continue the proof and pretending it's okay. Pn minus 3 holds because it's less than n. Therefore, we have a solution. And then to solve Pn plus 1, just add one more 4-cent stamp, correct? That's how we would solve this, right? So now is the question, what is it that I need to do? I have to make sure that n minus 3 is at least 18. I have to be within this range here. So for instance, if I started with, you remember, think of this as always as going up a ladder, right? And I'm already on the 18th step, and now I have to go to the next step, okay? So if I want to do the next step, 19, then I'm subtracting 3 from it, I get 16, but I don't know how to do 16. And in fact, I think perhaps 16 might not be possible. No, actually 16 was possible, but we don't know that, right? So just to be on the safe side, let's do P19, because that's what I'm trying to show, but I don't know how the proof doesn't apply for n equal 19. Okay, if n is 19, I cannot do this proof because n minus 3 is 16, and I don't know. I only know, this tells me you only know for between 18 and n. You don't know it for 16. So let's do it separately for 13. Sorry, for 19. How do we do it with 19? It's 19, I think, is 7 plus 4 plus 4 plus 4 plus 4. Okay, so now we're good there. Is that the only problem? Well, let's go on. If n would be 19, and then I'm trying to prove it for 20 now, right? So we go again 1 up. We're trying to do it now for 20. Then, so that would be from 20 we subtract 4, that gives me 17. Again, it's not in the range, so I cannot appeal to it. So I have to do 20 as well, separately. So we do 20. P20. 20 is, let's see, how do you do 20? So it's a multiple of 4, so that's, I can do it, so that's okay. All right, so 20 is also okay. So if n is 20, so I have now 18, 19, 20. What about if n is, if I'm, I want to prove it for 21, okay? So I know it's, so now the n that I'm going to look at here in this thing, n is 20, okay? Again, so I'm trying to prove it for 21. What do you do for 21? Well, you subtract 4 from 21, you get 17. Damn it, I don't know 17 either because it's not within the range yet, right? So I also need to do P21 before I cannot, my proof doesn't apply yet. So 21, how do you do that? Well, that's a multiple of 7, so I can do it that way, okay? One way is, sometimes there are more ways, but one way, once you have one way, it's enough, right? So now, if n is at least 21, then I'm good, right? If n is 21 or more, then if I subtract 3 from it, so if I subtract 3 from it, if I do this trick in my proof, then I'm guaranteed to be at least 18. And of course, if I subtract 3 from n, it's going to be smaller than n. So this n minus 3 ends up in this range here. And so my proof works. So now this proof is okay. But what we needed was n had to be at least 21. Okay? So, and in other words, let's try to think about it a bit backwards. What do I need? You notice that I'm subtracting 4. That's my technique. I'm going to subtract 4. That's the smallest amount. And that's why I need the first 4, because for the first 4, subtracting 4 is going to get me below. Understand? If I subtract 4 from each of these numbers, 18, 19, 20, 21, I'm less than 18, which is something that I don't know anything about, so to speak. I mean, of course, I can check it out, but for instance, 17 doesn't work. We know that. Well, we don't know that, but you can try and it doesn't work. So, I solved it, but now that you're used to this, what you have to say is this, okay, how does it really work? Well, if I have to do this with 2 amounts, I take the smallest amount, I have to do, and then there's a starting point, I have to do the first so many equal to the small amount that I have to do first those 4, here, in this case is 4, prove them separately, and then I can now take n, at least this number, the last number here, because then whenever I subtract 4 from that number, I am in good shape. Well, 3, because I mean, remember, we do, yeah, it's a bit, because if we start from 21, we'd actually try to prove it for 22, and then subtracting 4 from 22 is 18, that's why it works, okay? It's a little bit, you have to keep track of what you're trying to do here all the time, right? So that's how it works. Okay, I hope that's enough explanation now for you to do this on the quiz.